Hey guys, it's Mrs. Spiro. So we're going to go ahead and continue chapter 6. So chapter 6, I'm going to flip this over so you can see what we're talking about. It looks like this, and everyone should have this. So whether you're transferring from a different class, we all stopped at the same place, so we all should be at the same point. So here we are with chapter 6, and I am literally jumping to page 10. So we're going to learn more about rectangles than you probably ever thought you would. You're thinking rectangles are one of the easiest ones, but it does get kind of tricky here. So let's go ahead and get going. If you're just joining us, usually I do 2 lessons and then you have an assignment and you have 2 days to complete that. I'm breaking this down to doing it's the same thing, but I'm going to stop. After I do rectangles, I'll stop the video and then restart and do a different video for the next lesson. So it's basically the same thing, but I'm breaking them down into 2 lessons because according to that survey, you guys suggested maybe I do that because sometimes you guys wanted a break and then you would have to find where you stopped, and it was kind of a pain in the drain. So we're going to go ahead and try this and see how it goes. All right, so rectangles. All of you should know it's a quadrilateral with 4 right angles. Right angles, or 90-degree angles, I should say. All right, so here we go. If you know that you have a rectangle and your diagonals would be congruent. So your diagonals are congruent. So that means this and this are equal, and this are equal. This becomes a midpoint. So that is why these 2 are equal and then these 2 are equal. This whole thing, MK, is equal to JL. Okay. So if rectangle diagonals are congruent, okay. But it doesn't really talk about the pieces, but the pieces are also congruent. So that's very important. Okay. So this next one also talks about the diagonals, but it's like the flip-flop. So if the diagonals are congruent, then it is a rectangle. Kind of like the opposite of. So again, we have these diagonals. So if WY is equal to ZX, and we know that this side and this side are equal, and this side and this side are equal, then it would be a rectangle. So then it is a rectangle. So WY is congruent to ZX, then it is a rectangle. Also, you need to know, like I said before, just don't forget, if this side is 6, this side is 6. If this side is 5, this side is 5. All right, so let's put this into practice. So AE here and EC here. Well, what we learned is these 2 are equal to each other, so we can find the whole thing. We're going to have to do a little extra work on here. I can see what I'm talking about. Okay, so let's go ahead and put them equal to each other. So 3x plus 3 is equal to 5x minus 15. I always do red rover, so the smallest one over just because that's who I am. But you do it how you want to do. And then I'm just going to add my 15 because I know I need to do that. So 18 equals 2x divided by 2. X is equal to 9. Well, that's not what it's asking. It's asking for this whole thing. So now we need to substitute that 9 here. What is that? 27, 28, 29, 30. And then we have 2 of those, right? So this part is 30, this is equal, so 2 times 30 equals 60. Okay, again, this is equal to this. We found this part was 30, therefore this side would be 30. So this side would be 30, this side would be 30, and so this whole line would be 60. Okay. Next, RTU, so that means T is our angle. So this RTU, so right here is 8x plus 4. And then SU, the U is in the middle, R, and this right here is 3x minus 2. All right. So that is different than this. These two, so we have this and this. I'm going to mark it over here. So that's how they're congruent. So this is congruent to up here. This is congruent to here. These two together should equal 90 degrees. So they are complementary. So they equal 90 degrees. So I'm going to say 3x minus 2 plus 8x plus 4 equals 90 degrees. Again, you're like, how do you know that, Mrs. Spiro? These are different. And this makes a 90-degree angle. Again, it is just sometimes very difficult, but that's the reason why we're doing notes, so you can say, ah, okay, that makes sense. So now we're going to combine our like terms. Plus 2 equals 90. 11x equals 88. As you can see, I'm probably taking a lot of shortcuts. So this one said find x, and we found x to equal 8. Oops, can you see that? All right, next page. Ooh, see, it looks like fun. So if this angle ABD, again, BABD, so this one here is 7x minus 31. The key is going to be label these, draw your own pictures if you have to. CDB, so CDB, this one is 4x plus 5, okay? So if you think about this, these are alternate interior angles. So this is parallel, right? Parallel. This is also parallel. This is a line that crosses. So these are alternate interior angles. Alternate interior angles. Okay, so let's write that. Alternate interior angles are equal. Okay, so now we just set them equal to each other. 7x minus 31 is equal to 4x plus 5. Minus 4x, add 31. What is that? 36. Divide by 3, and x equals 12. Okay, find the measure of ABD. So ABD, and they're equal to each other. So ABD, 7 times 12 minus 31 equals. Where's my nifty calculator? $53. And there you have it. All right. Next, I think this is an excellent example. My husband does windows and doors, and they have to be square. And I see him doing this all the time. He's always checking the diagonals, which makes me laugh because I'm like, come on, it looks square to me, or it looks rectangular to me. All right, so I'm going to label everything. Again, I'm a picture person. This is 12. This is DA is 35. BD is 37. AC is 37. And BC was 35. Okay, so we know this is a rectangle here. But what you don't understand, which I thought was interesting when I watched my husband, you don't know that these are right angles until my diagonals are equal. So to prove, so you have to have right angles, 90-degree angles. Therefore, your diagonals must be congruent. Okay, so my diagonals are both 37, so 37 is equal to 37, so we got it. Check. And then what theorem was that? We just saw that on this other page. So the diagonals, if a parallelogram is a rectangle, then the diagonals. So that's 613. If the diagonals are, so actually it's this one. So if the diagonals are congruent, then it's a rectangle. So 614. And let's just put diagonals of rectangle. Okay. Diagonals of rectangle. Sorry, that's the theorem. Okay. And again, that's very important. Like I said, just because these are equal or these two are equal does not mean it's a rectangle. They have to have those 90-degree angles, and the only way to prove that is if your diagonals are congruent. All right, so let's go ahead and plot our points. You plot yours, I'll plot mine on this little itty-bitty grid. Straight edge would be nice. Now, how can we prove that these are congruent? You know, I'm a huge Pythagorean theorem person. So we need to make sure that our diagonals are congruent. And I should have labeled these. Doggone it. So J, K, L, M. Good, that was easy. All right, so let's try our diagonals. Let's go to M to K. And it says you can use the distance formula, but you know I'm going to change that to the Pythagorean theorem. So I'm going to, from M to K, I don't like this because you can't really see. So I'm going up 1, 2, 3, 4, 5, 6, 7 over 1. I don't think that's what I want to do. 1, 2, 3, 4, 5, 5. Okay, from here to here, I need to make a right angle. And the reason why I'm hesitating is because it's going to get really messy here because this is so small. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, L to J. So 5 squared plus 5 squared. Okay, let's do this one. So this one, I was trying to go up. Did I do that one wrong? Is it 7, 1? 7, 1. So 7 squared plus 1 squared. 5 squared plus 5 squared equals square root of 50. And then 7 squared plus 1 squared equals the square root of 50. So yes, my diagonals, that's MK, are congruent. So these are my diagonals. Check. So I guess we need to see, basically that means they're congruent. That's it. You could check I guess you could check all of these to make sure. So this is over 1, 2, 3, 1. This one is 3, 1. This one is up 1, 2, 3, 4, 5, 6, 2. And this is 1, 2, 3, 4, 5, 6, 2, if that makes sense. So the sides were equal as well. But this is all you needed to do, is check those diagonals. Okay? Again, I'm a huge Pythagorean theorem person. To me, it makes it a lot easier. But you need to know how to make those right angles. And it was very difficult since this was so small, and I apologize. So if you need help with this on an assignment, please let me know. Also, make sure you have some sort of graphing paper. I will put some online if you need to print it, or sometimes you can graph on Desmos. You can try that. I'm trying to think of what other options you could have. All right. That's it on rectangles. So I'm going to stop this video, and then I'm going to start the next one. And so you can decide whether you want to keep going or just take a break.